functions. We're going to look at functions in equation format a little bit. We're also going to look at window on a graph and calculator, kind of how that works. Do a few things with the calculator today. Still just exploring some functions. This chapter to me is a little bit boring because we're kind of picking up some like skills that we were like, why would you ever use that, right? These skills do translate better in where it will make algebra easier throughout the year. A lot of things will go smoother on the things that do apply to real world things. So kind of bear with me through this chapter. It is a lot of notation, a lot of calculator skills and things like that. It's a little bit boring. We'll get out. So the top one says, determine if the following expressions represent y as a function of x. And that's a tough question because I don't have a graph and I don't have a table of numbers. So I'm going to have to think about it as many ways as I can. If I could graph it, that's the easiest answer, right? Graph it and do a vertical line sense. To do that, I would have to get y by itself. So I'm going to show you guys some tricks on equations on how to tell if they're functions or not. So the first one, let's get y by itself and graph it. Subtract the 3x squared over. And divide by -1. And put that in y equals. My question is it a function or is it not? I divided. It is. Sorry. Y is negative, but then I'm going to divide that to get it completely by itself. Sorry, my little cursor was on top of that. Okay, so put that in your calculator and y equals. What does it look like? It looks like a parabola. Is that a function? Remind me what's not a function. A circle, something where we have something on top and bottom, right? So this is a function. In fact, I would say if you can type it in one thing in your y equals, it is a function. Your calculator only graphs functions. Your calculator can't graph circles, sort of. And I'll show you what I mean by that. So if you can put y equals by itself pretty easily, it's probably a function. And then I'll show you one that's not a function. This next one, x squared plus y squared equals 5, is not a function. You might recognize x squared plus y squared equals 5. You remember the equation of a circle we learned from the ACT? X squared plus y squared equals r squared. So this is a circle with a radius of square root of 5. Let's go ahead and try to get y by itself. See what that would look like. And then if I did get y by itself, I would get, what happens when you square root? When you square root when you're solving an equation? Plus or minus, right? How do you type plus or minus in your calculator? You have to type two different things in, right? So go to your calculator. In y1, type the square root of 5 minus x squared. Everyone do that. In y1, type the square root of 5 minus x squared. In y2, type the negative square root of 5 minus x squared. Which part? Gross. You sure? I was thinking of what it was. Oh, how did I get squared is 9. And negative 3 squared is 9. So when we solve that, we always plus or minus the square root of it. So anytime you take a square root when you're solving an equation, you put plus or minus.
I don't know what happened.
Okay.
Okay, it did something really weird.
I'm sure. When you graph that,
I didn't get my question. Can I press graph?
okay. Whatever you deleted must have had a problem.
Oh, okay.
I bet you used the negative symbol instead of a minus sign or vice versa somewhere. That would be my guess. Did it say error?
Oh, no.
No? I don't know what was there. Okay, so the square root, did we put those in y1 and y2? It graphed a circle, didn't it?
Yeah.
Well, it's an oval. It looks like an oval because your axes, look at your axes, you're wider on one than the other. You see what I mean by that? You're not zoomed square. If you zoom square, it'll look like so if you care to do that. But anyway. But it's a function. It's not a function. Now, it took us some work to get there. You can always do this work, and it's great. But I don't always want to have to do that. Do you? So we're going to kind of look for some clues. So y value is ever squared or to any even power, then it's not a function. Because you'd have a plus or minus when you solve. So I'm going to skip the solving part, and if y is ever to an even power, I'm going to go, that's not a function. Well, why not? Well, if I put two different y values in there, it's going to give me the same x value. Negative 4 and 4 for the y value is going to give me the same x value. So I have one x value that's going to two different y values. And so that's why it's not a function. So anytime the y has an even power on it, it's not going to be a function. That makes sense. So shortcut for you. That does show up on the ACT sometimes where they will ask that question. And this is perfect work to get there. And if you have to, do it. If you get stuck and have to do it, do it. But we can shortcut that and go, okay, y is squared or y is to a fourth power, not a function, because it would have a top and a bottom piece. Okay, the next question. Fill in the table of values and plot the points on a graph. How many turning points does the graph have? So I'm going to go through and plot these values. I'm going to do it by hand, and then we'll also look at the calculator. If I want to find the y value when x is negative 3, how do I do that? And it has a function up there, x cubed minus 2x. Plug it in for x. So negative 3 plugged in for x. Negative 21, is that right? Yes. Plug in negative 2. Negative 4. Plug in negative 1. 1. That's 1, is that right? Just check my work. Doing it in my head, probably shouldn't do that. X cubed minus 2x. Everyone getting it? No? So in my calculator, first I'm going to type negative 3 cubed minus 2 times negative 3.
So we're supposed to put in.
And it just in the home screen. So we're just finding the y. Now I do want to show you a shortcut. It's just a calculator trick. I like it. You can use it if you like it. minus 2x and y equals in y1. So delete this circle and put x cubed minus 2x in y1. Put x cubed minus 2x in y1. I should probably just pull this out so you see what I'm doing. This is going to be a nice little calculator trick for you. Yep, use the table. I'm going to go x cubed minus 2x and y, whoops. X cubed minus 2x and y1. Go to second window, which is your table setup. You'll only have to do this once. Your calculator will stay this way after this. And put your independent variable on ask and push enter. Independent variable on ask and push enter. It is my favorite way to use the table because then you can type anything you want into your x and it'll give you the y value. So you don't have, you know how you normally have to scroll through the table? You don't have to scroll, you can just type. I like that. If you don't, you can change it back when we're done. Go to second table. If you have something in there, you can just delete it. Use the delete button and it'll delete anything that's there. Most of you probably don't have anything in there because it's the first time you've used your table on ask mode. And then you can type -3, -2, -1, 0, 1, 2, 3, and 4. And it'll give you all those values in moments. Okay? So, cool little calculator trick. Anytime you want to plug a bunch of numbers into the same function, that's a great way to do it quickly. You don't have to do it, but random calculators don't worry. Okay. Then it asks me to plot those points on a graph. And so I'm going to look at the graph. I also could just push the graph button and look at the graph there as well. So -3, I get -21. -2, I get -4. My graph is a little strange. 0, 0. Choose 4. And 3 plus 1. And then I have another one, but no, no, that's it. So if I look at this graph after plotting this place, it looks something like that. I plotted it by hand. We're not going to do that real often. You could have also pushed the graph button on your calculator. We get kind of the same picture. Now, let's talk about when it's nice to plot a couple points. Have you ever tried your calculator window and don't see anything? Try to get a picture in your calculator, nothing shows up. A lot of times it's because our window is incorrectly set. So today we're going to look at how we can kind of set a window using some points and getting a window in an area we see it. This is a strange question in your homework basket tonight, so I just wanted to show you what I meant. How many turning points does this graph have? So how many times does it turn around? Two times, so it has 2 turning points. Any questions so far? Today our focus is going to be on window and using your calculator for graphing. Okay, so first I want to talk to you about your graphing window. If you will, get your calculator out and push the window button. A lot of times math teachers take it for granted that you know what this stuff means. So we're going to talk about what this stuff means. Y-min, X-min, X-max, X-scale, at Y-min, Y-max, Y-scale, and Y-resolution. all of that random stuff. So push the window button. This is what we're going to talk about defining today. Okay. So the first thing we're going to talk about is the X minimum and the X maximum. The X minimum and the X maximum is the smallest value that is shown on the x-axis and the largest value that is shown on the x-axis. So if you have a grid in your calculator, the X minimum is this value. The farthest left the graph goes. The X maximum is the farthest right the graph goes. One of the most common calculator problems that I see is someone will bring me a calculator and say, my calculator's broken. And it'll say error window range. Have y'all ever gotten an error window range? Well, a lot of times someone will type in their window 10 for the X max and 10 for the X min. Why is that a problem? You have to have something in between. So if you do 10 to 10, you're not getting a graph at all. And so your calculator pops back an error. It says window range error. It's saying, you didn't give me anything to graph. And so that's what it means when it says that. If you do really want a negative 10 to 10 window, your minimum has to be negative 10 and your maximum has to be positive. If you rearrange those the wrong way, it'll give you an error. If you do 10 to negative 10, it'll give you an error because it would say that's not correct. That's not the minimum and the maximum. The X scale is the distance between tick marks. So if your X scale is 1, you get a tick mark every 1 unit. Why is that good to know? Well, if you change your window to be like negative 200 to 200, if you don't change your scale, your y-axis ends up looking like a bolded black line because it has a tick mark every 1 unit and you're going 200 units. So it ends up just making your make it look like a dark black line. Where you might want to see every 10 units a tick mark or something. So that's what your X scale is. It's when it has tick marks. Y min and Y max is the same except it's the bottom and the top. The Y scale is the distance between the tick marks on the Y axis. The resolution is something you shouldn't ever have to change. The only thing I would say is if you have Hunter, hold up your calculator. If you have a color calculator like Hunter's and you find it to be graphing slow, you could change your X resolution to be a higher number and it will make it graph faster. The older calculators without the color screen, they graph quick anyway, but the color ones do graph a little slower. So if you are feeling like it takes your calculator longer than someone else's to graph, ACT, that's an issue, right? If you're sitting there waiting on a graph to show up. So that's the only time I change my X-res is that color calculators, you may want to make your X-res just a little higher because it'll make you graph faster. Don't go too high or you'll get choppy pictures. It's how often your calculator plots a point. So those are it's 5. 5 would probably be too much. Although maybe I get a picture. I do. Let's see. What was it to begin with? 1? I'd say 2. 2 would probably be. It'll graph twice as fast. I'd say 2. Okay. Sketch this graph in the standard viewing window. Then sketch it in the one given. Which one gives you a better graph? So first of all, go in your calculator, type x squared minus 16 in your y1. To zoom to your standard viewing window, everyone push zoom 6. That will always take you back to a negative 10 to 10, negative 10 to 10 window. So just type that in and then go to zoom 6. That'll get you your standard viewing window, which is negative 10 to 10, negative 10 to 10. I'm glad that you changed your X resolution. space. Yeah, push on. Now, if your calculator ever delays and you can't get it to quit, push on, it'll break whatever it's doing, and you can do something else. Okay, if you graph it in a normal 10 to 10 window, it does something like this, right? Would you agree that's not the whole picture? So now let's go to your window, push the window button, change the x-min to -6 and the x-max to 6, the y-min to -18 and the y-max to 20. Don't change your scales, just change the min and max. You could change your scale, but just for this. You put the -18 on the x scale, leave that at 1, and then change the y-min and max to -18 and 20. Which one gives you a better picture? This one, right? Because it gave you the full graph. So that's what this question was wanting you to do, is tell me which one gives you the better picture. Any questions? This one told you. Oh, this one told you. We will talk about that too. This one just told you. But since you asked, how did the calculator come up with such a great window? That might be a question you have, right? Go to your table really quick and type -6 in your table. Type 0 and type 6. Now, that's very few points. I just picked a couple. In those 3 points, when you type them in, what's the highest value you see? What's the highest y value? 20. What's the lowest y value you see? -16. Do you see how they picked their window? They just went below the -16 and they stayed at the 20. So that's a way you can choose those values, but find a couple of values and choose accordingly. Okay. Find an appropriate viewing window. So this is actually answering your question. Find an appropriate viewing window for this function using the given x values. Then graph the function. Find any coordinates of any turning points. So I want to graph this thing between 28 and 31. So they're giving me the x values, which is nice. They're telling me I want my x-min to be 25 and my x-max to be 31. So type in x minus 28 cubed in your y equals. X minus 28 cubed in your y equals. And then go to your table and type in some numbers between 25 and 31. I picked, but I did way more than you would have to do, probably. I just did every number between 25 and 31. So every whole number. So I did 25, 26, 27, 28, 29, 30, and 31. What is the lowest x value that you see there? -27. What is the highest one you see there? Positive 27. So do you think that would give me a good window? So it says find an appropriate viewing window. I would do my y-min as -27 and my y-max as positive 27. And you are given your x-min and x-max. Okay, so in your window, 27 to 27 for my alignment and math. If this is a question on homework, will I have to accept things other than just negative 27 and 27? Yes. Anything outside of it. Like if you did negative 50 to 50, would that give you a good viewing window too? Yes. Now, negative 1,000 to 1,000 wouldn't, because it'd make it so tiny you couldn't see it. And so I would have to accept a range of answers, but not just anything. So, did we get that picture? See what other questions we have. Using the given x values, then graph function. And it does say that on your homework. Do give me a sketch. It doesn't have to be great, but give me a sketch. Was it 25 to 31? And it looks something like that. Okay, so that's what we're looking at. It doesn't have to be, you don't have to label every tick mark or do anything like that. Just show me that you can graph it in your calculator. That's all I'm looking for there. Find the coordinates of any turning points. Do I have a turning point? Looks like I have one of them. You can use your trace button to go find, and actually it put me right on at 28. Does everyone agree that it looks like at about 28 is where it turns? So the turning point is at 28. So it says coordinates, so 28, 0. Okay. If the turning point is a minimum, you can use the minimum button on your calculator or the maximum button on your calculator. We will talk more about those on another day. For now, I'm okay with you. Okay, go ahead and write this down. I do have one more example. Write this down. Actually are.
Like this.
It's spread over a full year. So it's not any easier material, but you do have much longer to process it. So in that respect, it's easier. It's not, we are not dumbing down the material. We just are doing it over a longer period of time, which is very helpful. There's like some of the stuff that I'm teaching you that they would skip. They would just go, nope, they know how to do that. Like factoring would probably be something they would skip. All right, one more. Use a graphing utility that is a fancy word for a calculator. I use the same word against your books so that you would have a hard time with that. To graph the points from the table, also graph 12x minus 6. Do the points to graph of the line. So I'm going to graph these points on the table. -3, -42. -1, -18. Now I put a grid up here. You can label your grid by any amount of tick marks you want to, just like you can in your calculator by anything you want to. Looks like I counted by tens.
On the side of it.
Another day, we will do something like that. Today we're just kind of looking at graphs visually. You'll get there a little bit more complex work. 9, and 11, 1. Okay, so I plotted those points. And then it says graph 12x minus 6. Do you know how to do that by hand? And we've done that before, right? Last test, we did that. -6 is the y-intercept.